Hello everyone. Welcome to the solution of LeetCode problem 153 named Find Minimum in a Rotated Sorted Array. In this problem, we are given a rotated sorted array and we have to find the minimum. So here we can see that in the first array has 5 elements, which is 3, 4, 5, 1 and 2, and here the minimum is 1. In the second array, it has several elements, which is 4, 5, 6, 7, 0, 1, and 2. And here 0 is the minimum. And in the third example, the array contains 4 elements, which is 11, 13, 15, and 17. So here 11 is the minimum. And we have to implement this algorithm by using big O of and runtime. And here the constraint are the array length can be in between 1 to 5,000, and each of the array element can be in between minus 500 to, minus 5,000 to positive 5,000. And all of the element in the array are unique, and the number is sorted and rotated between 1 to n times. Okay, this is the pretty straightforward problem statement. That means here we are given an array which is rotated and we have to find the minimum. I hope you understood the problem statement. Now let's move on to the algorithm. Now here, let's consider the first example. The array contains 5 elements initially from 1 to 5. Now, if I rotate this array one time towards the right, all of these elements will be shifted 1 unit right. So here it will become 1, 2, 3, and 4. And this element 5 will come into the first place. So the 5 will be presented here. This is the first rotation. Now, again for the second rotation, all of these elements will be shifted 1 unit in the right side, which will be 5, 1, 2, and 3. And this last element 4 will become into the first side. Now again in the first rotation, all of these elements will be shifted one time towards the right, and it will become 4, 5, 1, and 2. And here the last element 3 will come into the first place. So we can say that 3, 4, 5, 1, and 2 is the final array after 3 times rotation towards right. Now we have to find the minimum number in this rotated array. And we are clearly seeing that the minimum number among these 5 elements is 1. So we have to find this 1. And we have to perform the algorithm in big O of log and runtime complexity. And we know that for any of the searching, if the algorithm runs in big O of log and runtime complexity, we can simply use the binary search here. So for the binary search, let's say we have take this pointer as the low and this pointer as the high. Okay, so far so good. Now their mid value is this 5. So here we have to check whether the high value is less than our mid value or not. So here we can see that our high value is 2 and our mid value is 5. So the high value is less than mid value. That means if the high value is less than mid value, it is ensured that the minimum number will be lie into this range. And otherwise, the minimum number will lie into this range. So this is the pretty straightforward binary search algorithm. Here we will check whether the high value is smaller than the mid. If it is, that means we have to shift our left pointer to mid plus 1. Otherwise, we have to shift our high pointer to mid. So let's see how this algorithm works with pen and paper. Now, left, mid, and right is pointing to the respective element. Now here we can see that the high pointer value is smaller than the mid. So we have to shift our left pointer. Now our left pointer is indicating the value 1 and high pointer is indicating the value 2. Suppose the mid pointer is pointing here. So now we have seen that our high pointer value is greater than the mid value. That means our high pointer value is 2 and the mid value is 1. So here the high pointer value is greater than mid value. So if this is the case, we have to shift our high pointer to mid position. Okay. Now, while we will apply this algorithm, we always check whether the left pointer always be less than the high pointer or the right pointer, we can say. So here we can see that our left pointer is indicating the element 1. Our mid pointer is indicating the element 1. And as our high pointer value is less than our mid pointer, so we have to shift our high pointer to mid position. So here our high pointer is also indicating the value 1. And this condition violates because low pointers is equal to high pointers here. And this condition violates, so we have to simply return the low pointer value. So here the low pointer value is 1. And 1 is the minimum among all of the elements. I hope you understood the algorithm and how this binary search works. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function find min, which is a vector as a parameter, and we are taking two variables, low and high. So here we apply the binary search where low is less than high, and here we are calculating the mid. And if the value of the mid is greater than the value of the high, we have to shift our low pointer to mid plus 1. Otherwise, we have to shift our high pointer to mid. Finally, we have to return the low pointer's index value. This is how the binary search works. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.